Hey, y'all, let's cover the final exam review. All right, so given the quadratic function, the one I have provided on the paper here, we want to know if it opens up or down. So let's start off with, this is the same thing as f of x is ax squared plus bx plus c, right? Coefficient of x squared is a, coefficient of x is b, and then the constant is c, which is 2. So if a, the coefficient of x squared, is positive, that means that it's going to open up. Okay, it's going to open up. So there's the answer to that one. It opens up. Or concaves. If you're going to see Angela next semester, make sure that you said that I said the word concave at some point. Opens up. Lord have mercy, that girl. All right, axis of symmetry. So axis of symmetry is the same thing as H, but it needs to be written as a line. And that it's a vertical line that X equals. All right, so X equals something. And in this case, it's negative B over 2A. All right, so we're going to take the B, which is the negative 3. We got a negative here. So negative 3 over 2 times A. So positive 3 over 2. All right, so X equals 3 halves or 1.5, since it's a non-repeating decimal. You could do that as well. All right, vertex. The vertex is HK. And remember, H is equal to the axis of symmetry version, the negative B over 2A, which we've already found is 3 halves or 1.5. And then K is just F of, K is equal to F of H. So in this case, F of 3 halves or 1.5. All right, so now we have to take the x squared minus 3x plus 2, and everywhere there's an x, because this is F of x, I need to plug in 3 halves or 1.5. Okay. When you square the 3 halves, it's 3 squared is 9, over 2 squared is 4, minus, this is over 1, 3 times 3 is 9, over 2, plus 2. Again, you could use the decimal version of this. It's totally fine. It's going to give you the same answer. So I just need to make sure we have a common denominator here that's 4. This one's only 2, so I need to multiply this by 2 over 2. And this one has a denominator of 1, so I need to multiply it by 4 over 4. 9 fourths minus 18 fourths plus 8 fourths is equal to negative 9 plus 8 is negative 1 fourth. Or if you did this in decimal version, negative 0.25. All right, so the vertex, that was my answer for this, is 3 halves, comma, negative 1 fourth, or 1.5, comma, negative 0.25. Next one is y-intercept. And the y-intercept is just letting, when x is 0, what is y? All right, so we're going to take the original function up here, x squared minus 3x plus 2, and I'm going to plug in 0 everywhere there is an x. 0 squared is 0, 3 times 0 is 0, plus 2, which is 2. So the y-intercept is 0, 2. X-intercept is where we let y, or f of x, equal 0, and we put the whole equation here and solve for x. A lot of you go straight to the quadratic, and I find this is so much easier than the quadratic. So x minus 2 equal to 0, and x minus 1 equal to 0. So x equals 2 and x equals 1. So our zeros, or our x-intercepts, are 2, 0 and 1, 0. All right, graph it. All right, I'm not going to ask you to graph anything but you should be able to know what this looks like. The vertex is 3 halves, so 1.5, and then down a fourth. All right, so over 1.5 and down right about there. There's the vertex. And then it goes through 2 and 1. So it goes through here and here. And then it has a 0, 2. So it goes through here. So that kind of helps me. Got my zeros, my vertex, my zeros, and it goes up. So this will help you decide the next two pieces. The domain for a quadratic is always the same. The domain is always negative infinity to infinity. The range, however, is where things get fun. Remember, range is from bottom to top. So the lowest to the highest, the same thing the domain is from lowest to the highest. So the lowest point we have is right here, and that is going to be our K for our vertex, which is negative 1/4 or negative 0.25. So negative 1/4, and it goes to infinity because it goes up forever. All right, that is the first part. Let's go to factoring and solving. All right, we've got 3x cubed minus 15x squared minus 18x is equal to 0. I look to see what they have in common. They have an x in common and they have 3 in common. So I'm going to factor 3x out of this. When I factor from this one, I'm left with x squared minus 5x minus 6. Okay, now I'm going to keep factoring. I can do 3 and 2 or 6 and 1. I'm going to have to do 6 and 1 because we're going to be subtracting them. 3 and 2 work if you're adding them. And I need the 6 to be negative because the middle term is negative. All right, I factored it as low as I can get it. Now I'm going to take each one of these terms and set it equal to 0. A lot forget this, so be very careful. Don't forget your x there. Anytime there's an x that's been pulled out, you need to set it equal to 0. If there's a constant, you can just divide through by the constant and get rid of it. You can't get rid of an x. Divide both sides by 3. We've got x equals 0. Add 6 to both sides. X equals 6. Subtract 1 from both sides. X equals negative 1. So for factoring and solving, those are our zeros. X equals 0, 6, and negative 1. All right. 1 over x minus 2/3 is equal to 5. Common denominator, 3x. So I need to multiply each one of these through by 3x. All right, and then there will be no denominator when I do this because there's an equal sign. So the x is reduced here. The 3 is reduced here. So this leaves me with 3 times 1 minus x times 2 equals 5 times 3x. I'm just throwing an extra step in there. You don't have to do that, just to show you what happened. All right, now let's solve for x. I can move the 2x over here. Seems the easiest thing to do. And then solving for x, I just divide both sides by 17. So x equals 3/17. Cool. Next one is negative 2x squared plus 5x plus 4. I'm going to quadratic equation this bad boy because anytime there's a coefficient that I can't factor out for x squared, I mean, I could factor out, but I don't want to deal with a fraction and for the middle term. So I'm just going to say A is negative 2, B is 5, and C is 4. And I'll use x equals negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. And I just plug them in. So b is 5, so negative 5 plus or minus the square root of 5 squared minus 4 times a times c. All of this over 2 times a. Negative 5 plus or minus. And so this is 25 plus 16 times 2 is 32. So this is 57 over -4. Okay. Well, you can take the square root of 57 and add it to -5, divide by -4, or you can just leave it like this, honestly. Otherwise, you're going to be giving me decimal answers. So I will accept that. Next is absolute value. Nope, 2. 2 times absolute value of 3x minus 1 equals 7. So the first thing you want to do is get the absolute value by itself on one side. I'm going to add 1 to both sides. All right, I'm going to divide both sides by 2. Now, and only now, can you separate it. Because it's an equal sign, it's absolute value. 3x minus 1 equals the positive version of 4, and 3x minus 1 equals the negative version of 4. Okay, we solve this. Add 1 to both sides. Divide both sides by 3. Add 1 to both sides. Divide both sides by 3. There you go. Next, answer in interval notation. Okay. Well, you just need everything on the same side. So I'm going to add 5x and subtract 14 from both sides. And set it equal to 0. Now I'm going to factor 7 and 2. All right, and then x plus 7 equals 0, x minus 2 equals 0, x equals -7, x equals 2. Here is where I draw my number line. And I know that because of this, they're going to both be dots, not circles. They're both included. But it's greater than. And it didn't switch as we went through and got down to here. Once you hit the factoring point, you've got everything on one side. In this case, it's greater than or equal to 0. You could test this by plugging 0 in here. So is 0 squared plus 5 times 0 minus 14, is that greater than or equal to 0? If so, 0 will be a part of this and it's in between them. It's not. This gives us -14 greater than 0, and that's not possible. So your answers are going in this direction, and that's the case with any of them that are greater than. But you could always check it in case you forget that. And I always choose to check 0 because why wouldn't you? All right, so now I want to put this in interval notation. -7, we got negative infinity to -7 along, or 2 to positive infinity. And there's my interval notation. All right, don't have one like this last one on your exam. Hold on one sec, I want to double check. All right, let's just do this one. You need to know how to do it anyways. So if you were to multiply both sides by 1 minus 2x, you would have 3 is greater than or equal to 0. You would totally lose the denominator. In this case, however, you need to do something a little bit different, and you need to take the 1 minus 2x, and you're going to make it greater than 0. It can't, if you had, I'll show you. We'll just make it greater than or equal to 0, just so I can show you what to do here. Subtract 1 from both sides. All right. You get -2x is greater than or equal to -1, and then divide both sides by -2. X is greater than or equal to 1/2. Okay. Here's the problem with this. If you plug this 1/2 into here, you're going to get 0. Oh, which that would give you 3/1. That works, though. That does work. Give me just a second. I want to look at the graph for this. Well, it does include the 1/2. So it's going to have to be included as well. No, but it can't be because it makes it 0. Yeah, okay. So that means that what we're going to do with this is we divided both sides. Oh, I didn't flip my sign. There we go. When you divide by -2 or multiply 3 by the negative, you flip your sign. So this means, do we need to answer this in interval notation? Yes. So my answer for this is from -infinity to 1/2, and it is included. All right, next version. Find the real zeros of the following function and state the real zeros for each and whether they touch or cross. So we're looking for the multiplicities. All right. So f of x is equal to x times x minus 2 squared x plus 1 cubed. So this one is x equals 0, and it is odd because it is a 1, the multiplicity. This one is, you're going to take the x minus 2 and set it equal to 0, and you get that x is equal to 2. It is even because it has a multiplicity of 2. And then for this one, set x plus 1 equal to 0, you get x is equal to -1, and it is odd because it has a multiplicity of 3. All right. And so the odd ones cross, the even ones bounce or touch. Express the product, 5 minus 7i times 4 plus 2i. So I'm just going to FOIL this. 5 times 4 is 20. Outer is plus 10i. Inner is minus 28i. And last is -14i squared. Remember, I squared is equal to -1 because I is the square root of -1. When you square it, it's -1. So now we just combine like terms. I can combine these two. This becomes -1. So this becomes positive 14. 20 plus 14 is 34. 10 minus 28 is -18i. And you want to answer this in A plus BI format. Okay, which I asked you to do here. Answer all three of the following. Write the answers in simplest form, given the functions defined as f of x and g of x. All right, so we've got f of 1, which means everywhere there's an x for the f function, we plug in 1. So 3 divided by, it's x minus 2. We're going to make it 3 over 1 minus 2, which is 3 over -1, which is -3. Cool. So f of 1 is -3. All right, f of g of x. So we're doing the compositions. This can be written as f of g of x, or it can be written as f of g of x. They mean the same thing. They're just the compositions of functions, which I wrote on here as well. Okay. And so we've got the two functions. F of x is, rewrite this. 3 over x minus 2, and g of x is 2 over x. So I'm going to take the f function and plug the g function into it. So f of g of x is 3 divided by, now I'm going to take the 2 over x, and plug it in where the x is, minus 2. Done. I mean, I could simplify this for sure, but it's not going to change anything. So I just want you to show me that you can compose them. All right. Next one is f minus g of x. You need to be able to do all of them. X plus g of x, f times g of x, f divided by g of x, all of them. All right. So we're taking the f function and subtracting the g function. This one I do want you to finish. I do want you to simplify this. So we're going to multiply both by x and x. Well, I'm going to multiply this one because the denominator, the common denominator is going to be x minus 2. This one is missing x, so I'm going to multiply it by x. This one is missing x minus 2. Okay, so 3x minus 2 times x minus 2. All of this is over x, x minus 2. Now they have the same denominator, so we can combine them. I'm going to distribute my negative 2 over my binomial. I get 3x minus 2x plus 4 over x minus 2. This becomes x plus 4 over x minus 2. And that's it. Given the function, find the difference quotient. Cool. So we're using f of x equals 3x squared minus 5x plus 4. The difference quotient is f of x plus h minus f of x. All of that's over h. So for the first one, I'm going to take x plus h and shove it in everywhere there's an x. X plus h. All right, then we're going to subtract the original version. Don't forget the parentheses because you have to distribute this negative. And all of this is over h. Okay. I'm going to FOIL this. So this is 3x plus h, which is 3 times x squared plus 2xh plus h squared. I'm going to go ahead and distribute minus 5x minus 5h plus 4. Distribute my negative. Negative 3x squared plus 5x minus 4. And all of this is divided by h. You distribute my 3. 3x squared plus 6xh plus 3h squared. Just going to bring everything else down. Okay. Now let's get rid of things. Gone, gone. We're left with 6xh plus 3h squared minus 5h. And so each one of these is over h. It's better to do it this way. You'll make fewer mistakes. So this becomes just 6x plus 3h minus 5. That is the difference quotient. All right, given the function, find the inverse. So if the function is that, the inverse is just the first thing you do is you switch f of x to y. Then you switch places with the x and the y. And then you solve for y. So I subtracted 3 from both sides. And I got x minus 3 is equal to y cubed. The opposite of y cubed is cube root. So I'm going to take the cube root of both sides. So y equals the cube root of x minus 3. And then finally, I didn't ask for y. I asked for the inverse. So I'm just going to change this to the inverse of x is the cube root of x minus 3. Okay. Find the equation of the line pictured here. Okay, you're going to have to look at it on your side, either that I have to share my screen. So you should have already worked through these problems. This is just you checking yourself. So I'm just going to choose a couple of points here to find my slope. I'm going to choose 0, 4. That goes through the y-intercept. And I'm going to choose negative 2, 0. Because those sound easy. I need to find my slope first, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to label. All right, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So negative 4 over negative 2 is just 2. There's my slope, but they want the equation. Well, the equation is y equals mx plus b, and y equals 2x, and I already know my y-intercept is 4 plus 4. Booyah, But what if you're like, oh, it doesn't cross the y-intercept, or you don't know what the y-intercept is, or it's a fraction, or you can't tell what it is. Let's just pretend that's the case. You can choose a point, usually the one you've chosen here. I'm going to choose 2, 8. Okay, just for shits and giggles, I'm going to choose 2, 8. Pretend like I don't know this and I'm looking for it. Pretend like I have y equals 2x plus b, and I'm looking for the y-intercept. I can use any point that's on that line to find the y-intercept just by plugging it in, where 8 is my y, 2 is my x. Sorry, my dog's snoring. 8 equals 4 plus b, subtract 4 from both, and b equals 4. So y equals 2x plus 4, or f of x equals. All right, find the equation of a vertical and a horizontal line passing through the point. This always gets folks. These are the easiest questions. And the easiest ones are the ones y'all don't spend as much time on, and so you mess up on the exam. Be careful, don't give away points like that. All right, so we've got a point that's 7, 9. So we want the vertical line and the horizontal. So notice these are x's and y's, right? It's x and y. Vertical line is just goes through the x-axis, right? It doesn't go through the y-axis at all unless it's the origin line. So it's going to be x equals, well, what does x equal in this point? 7. Booyah, done. Next one, horizontal. Well, the horizontal line only goes through the y-axis unless it's the x-axis. So it's going to be your y equals whatever the y value is. You can't just say 7 and 9. That doesn't work. You need to put it in linear function form. So x equals 7 and y equals 9. Otherwise, it doesn't make sense. Find the equation of the line passing through the point 3, 2 that is perpendicular to the line. We're going to have to do one that's parallel as well. Okay, cool. We'll do both. So we've got a line, 3x plus 2y equals 5, and we want it to go through 3, 2. I'll do parallel first just because it's the same slope. First, we need to find the slope for this. So I'm going to solve for y. And divide both sides by 2. Y equals -3 halves x. That's all I need. I need to know what this is right here. I need to know that the slope is -3 halves. For a parallel line, we're going to go through this point and we're going to use the same slope. So equals -3 halves. We've got a point, we've got a slope. We can either use the point slope formula or we can use y equals mx plus b to solve for this. I'm going to go ahead and use the point slope formula. Y minus y sub 1 is equal to m times x minus x sub 1, where this is x sub 1 and y sub 1. All right, so y minus 2 is equal to -3 halves x minus 3. I know you don't like fractions, so we're going to get rid of the 2 by multiplying both sides by 2. So to distribute this one, 2y minus 4, this one goes away, -3 times x minus 3, which I need to distribute, and then solve for y. Divide both sides by 2, and then y equals -3 half x plus 13 over 2. That is the parallel line because it has the same slope as the original function. Okay, now I'm going to do the perpendicular line. Perpendicular line is going to take that slope and it's going to be the negative reciprocal. So the slope is going to be positive 2/3. But we're going to go through the same point 3, 2. For this one, I can use y equals mx plus b so we can find b, just to give you a different visual. Here's x, here's y. X is 3, slope is 2/3, y is 2, and we're looking for b. All right, I'm going to go ahead and multiply first. . So, well, this reduces to 2. That's sweet. All right, and then just subtract 2 from both sides. Wow, that's right. X 2/3. Yeah. Okay. So it's just y equals 2/3 x. There's no y-intercept, or the y-intercept is 0. Okay. All right, next one. Graph the following piecewise defined function. So I'm not going to ask you to graph on the exam. I am going to ask you to give me the I think I do that. Let me double check this one. Hold on. Okay, I'm going to ask you to graph the piecewise function. But they're very simple. They're just graphing linear functions. It's not like I'm asking you to graph quadratics or anything. It's just lines. It's just linear functions. What did I give you as a question on this one? Okay, so I've got a quadratic, and then I've got y equals x. All right, we can do these. We can do these. So I'm going to use the quadratic as an example along with the line, just to show you what the expectations are. When I do piecewise functions, praying that I have a pencil. If not, I'm going to have to redo it. Nope. Why would I? All right. So let's see what we got here. We've got f of x is equal to 2x squared, and f of x is equal to x. For this one, x is greater than or equal to 1. For this one, x is less than 1. So you could put this in your calculator to draw it, or you could just graph it. It's going to probably take me 2 times to get through this. This one's easy because this is just the. Let me do this quick. This is just the basic identity line. That's all this one is right here on the right. Y equals x is identity, but it's when x is less than 1. So you would have to start at when x is less than 1. So it's not going to include this. And then everything to the left is less than 1. So my graph for this part of it, for the piecewise, let me draw this real quick, see if I can do this. Woohoo! All right. So there's my piecewise for this piece. Now I need to do the one for this one. And it's going to be where x is greater than or equal to 1. So if I plug a 1 in here, I'm going to know where this is going to start. 1 squared is 1. 1 times 2 is 2. So 1, 2, and it's included is going to start here. Okay. If you want to plug in the next number, 2, you can get your second point because it's only going to be to the right. I don't have to worry about 0 because it's greater than 1. 2, and I know a quadratic looks like that. 2 goes to what? 2 squared is 4. 4 times 2 is 8. So that'd be 1, 2, 3, 4, 5, 6, way up here. So like that is what that would look like. And it would just keep going. So there's my piecewise function. Okay. You'll have 2 lines, and you'll just need to make sure and restrict their domain based on what I provide you. All right. Graph the following functions using transformation. So on this one, you can either use words, or you can show me on, there's a graph that's provided, what the transformations look like. So with this one in particular, you would just need to let me know what it's doing. So f of x is the square root of 2x plus 1. Now, if I'm going to, hold on, I'm going to pull up Desmos. Okay, so this is what the y equals 2x plus square root of 2x plus 1 looks like. I don't want to see this per se. I want to see the steps it takes to get there, okay? So if you know what the toolkit function looks like, which is just y equals the square root of x, that's the toolkit function. So you can let me know, did it go up? Did it go down? Did it go right? Did it go left? Do we have a horizontal shift, a vertical shift? Do we have a stretch? Do we have compression? Well, all we have is a horizontal shift, and that's because it's inside here with the x, and we just have a horizontal shift Oh, actually, we have more than that. No, we've got a compression as well. Oh, okay. So it moves over from 0, 0 to negative 0.5. So we have a horizontal shift to the left, 0.5 or 1/2, however you want to say that. Okay. And then I'm looking at how this is landing. We've got this going to 0.5. Yeah, notice this, it should be hitting 0.5 here as well. If it was doing the, no, it's not. 2. Yeah, it's not. It's actually stretching further up here. All right, so that's y equals x. What would be y equals the square root of 2x? There it goes. That's what it's doing. Okay. So it's going to be 1 over b. All right, which is 2. Awesome. Okay. So you can show it like this. When you're showing it, you can show y equals square root of x, y equals square root of 2x, and then you've got the horizontal shift of y equals the square root of 2x plus 1. You can do it like that to show me that you understand the transformations that are happening. Okay. All right. Next. Oh, domain and range. Let's go back to that one. I just need to see the original. So the domain and range, the domain starts at negative 0.5 inclusive, and then it goes to positive infinity. The range starts at 0 because remember, it's going from the bottom to the top. It starts at 0 where y equals 0, and then it goes to positive infinity as well. All right, let me switch back. What's the next question? Is that indifferent? That is not 3 over x minus 1. Oh, they just want the domain and range for 3 over x minus 1. Well, let's put it into Desmos. 3 divided by x minus 1. Three divided by parenthesis x minus 1. Yep. Enter. So this is what it looks like. There's going to be a line both horizontally and vertically that it will not touch. Okay. And you can get really tight to see who it's getting really close to that it will never touch. So it will never touch the 1. Okay. So, and you can know that because if you put 1 where the x is, you would have 0 in the denominator, and that's undefined. So it's going to be from negative infinity to 1 with a parenthesis, not inclusive, or you're going to have from 1 to positive infinity, 1 with a parenthesis to positive infinity. That's the domain. That's what you can plug in. What you're going to get back is it's never going to touch the x-axis. So I'll show you on my paper what this is going to look like. Maybe. All right. So my paper, I've got for the domain for that would be from negative infinity to 1 and 1 to infinity. The range is going to be negative infinity to 0, non-inclusive, 0 to infinity. It will never touch 0 for the horizontal. This is domain and this is range. All right, next victim. We've got a quadratic and we want to find the equation and the range. Well, domain's always the same. It's just negative infinity to infinity. So please look at your quadratic so I don't have to show it on my screen. My vertex is HK, which in this case is at 3, 1. And the y-intercept's at 0, 7. That's all I need. And I can find the equation. Looking at it, the range is from 1 to positive infinity. All right, 1's included. So we've got y equals a x minus h squared plus k. All right, we're going to have to find our a. We're given the h and k here. So y equals a x minus 3 squared plus 1. Now I need to find a. In order to do that, I'm going to use my y-intercept, where this is x and this is y, and I'm just going to plug this in. And solve for a. Negative 3 is 9. Subtract 1 from both. Divide both sides by 9. So a is 2/3. There's my equation for my quadratic. Discuss the range and the domain. Write the exact value of the trig function, of the given trig expressions. Do not use a calculator. State the quadrant and the reference angles. Use calculator. Let's see what else I have here. I want to do some more before I go to the trig ones. I don't remember asking that question. What would f of x be if x equals 5? Let's see if I have that. I don't think I did that. No, that's not on the that's not on the test. All right, let's go. I'm not gonna do that one. A certain professor can be bought for a grade. I know I did a couple of word problems. Trig and okay. So these word problems are not going to be. The second one's going to be like what you're going to have on your exam. This one is going to be different from what you're going to have on your exam. Very different. In fact, this is just a linear function. That one is a linear function as well, but there's a certain way you're going to have to calculate it. Just read it. Give yourself some time to think about it. You're going to have to mull over that question. But the certain professor can be bought for a grade. I'm not going to do that because that's just a linear function that you're not going to have one like that exactly on your test. So I want to do this next one where it has a 15-foot ladder. We'll do the trig stuff and then we'll be done. All right, so we've got a 15-foot ladder leans against a building so that the angle between the ground and the ladder is 70. Building, ladder, and it's a 15-foot ladder. And the angle is 70 degrees. Make sure your calculator is in degrees, not radians. Find the answer up to 4 decimal places. So how high does the ladder reach up the side of the building? So we're looking for this value here. Using the 70 degrees and the 15 feet, we need to find the side opposite the 70 degrees. So we're looking for opposite. The 15 foot is the hypotenuse. So I need a trig function that uses opposite and hypotenuse, and that's sine. So sine of 70 is equal to the opposite over hypotenuse. You just need to solve for x. Multiply both sides by 15. I don't think I have it. Give me just a minute. I don't have a graphing calculator. I have to put this in my computer. In degrees. Okay, good. So I need 15 times sine of 70. So trig. Sine. Sine of 70 times 15 is 14.09. 5389. What do they want us to round to? 4 decimal places. So 14.0954. And this is feet. Please use proper units. Okay. Now I'm going to go back up and do the other ones. All right. Bear with me just a second. Okay, so the first one is secant of 150. All right, so 150 degrees is in which quadrant? It's in quadrant 2. Remember, quadrant 1 is where x and y is positive. and it goes counterclockwise. So quadrant 2 and the reference angle. So quadrant 2 is, here's 1, 2, 3, and 4. And this is secant of 150, and 150 is right here. All right. The ordered pairs, well, we don't need to do that right now. Let's do the reference angle. The reference angle is between the terminal side and the x-axis. So that's the reference angle. If this was 150 degrees and it's in quadrant 2, to find the reference angle, we just need to take the absolute value of 180 minus the angle, which is absolute value of 30, which is 30 degrees. That is the reference angle. All right. Secant, so that's secant of 150 degrees is equal to 1 divided by the cosine of 150 degrees. And this is without a calculator that I'm doing this. The cosine of 150 degrees is negative square root of 3 over 2. So this is going to be 1 divided by negative square root of 3 over 2, which is your x value, because remember cosine is equal to x. So this is 1 times negative 2 over the square root of 3, which is negative 2 over the square root of 3. But you're going to need to rationalize your denominator. So multiply by the square root of 3 over the square root of 3, which is equal to negative 2 square root of 3 over 3. That's the secant. All right, cotangent of 5 pi over 6. What quadrant is 5 pi over 6 in? Well, 5 pi over 6 is the same thing as 150 degrees, but we're going to do it in the radians. So it's in quadrant 2. And to find the reference angle for anything in quadrant 2, it is just the absolute value of pi minus the angle. And in this case, it's 5 pi minus 5 pi over 6. Okay, so we need to have the same denominator. 1 can be anything, so I'm going to make it 6 over 6 because it's the same denominator that way. 6 minus 5 is pi over 6, and it's already positive, so there's my reference angle. Cotangent. So cotangent of 5 pi over 6 is equal to cosine of 5 pi over 6, pardon me, over the sine 5 pi over 6. And you can just use your coordinates here. The cosine of 5 pi over 6, we just said is, goodness, is negative square root of 3 over 2. And this is divided by sine, which is 1/2. So keep, switch, flip, gone, gone. So negative square root of 3 is the cotangent of 5 pi over 6. All right, the next two are done with your calculator. Let me see if I can do it with my phone, which has apparently been blowing up. All right, calculator, turn it sideways. Okay. And this one does not have a degree symbol. Because it does not have a degree symbol, you're going to have to use radians. All right. This one does have a degree symbol, so you're going to use degrees. Please make sure that you're comfortable with that. And I don't know what's going on here because it didn't give me a scientific. Okay, I'm going to have to do my calculator here. So I'm already in degrees. So I'm going to go ahead and do the one for degrees on my calculator because I have it pulled up right now. 125. Oh, it's secant. So it's 1 divided by cosine of 125 equals. And so I got negative 1.7434. I think it wanted to go to 4 different directions. All right, now I need to switch the other one to radians, and I'm going to do 24.6, the sine of 24.6. Sine. Negative 0.5079. Interesting. All right. Nice. Last question. Is that it? Nope, I got these. All right. So I can't remember if I asked you to use, let me go look to see if I asked you to use reference angles. Yes. And the value. Nope, I did not. Okay. Determine the value of the trig function. Okay. So for the one I gave you, I didn't tell you what the angle was. I told you what tangent is. And so you're going to have to find the other side. You'll have your sine over cosine, but you're going to need to find your hypotenuse for that. Just to give you a little tip on that. All right. In this case, I actually gave you the angle itself, which is negative pi over 4. Now you can use reference angles to do this, but if you understand, remember, if you've got a negative, you're going in this direction and you're going negative pi over 4, you might want to use reference angles if to help you make better sense of this, because we're going to end up in quadrant 4. Right? And so you need to know who's positive in quadrant 4 and who's negative. Well, remember, it's A, S, T, C. Those are the ones that are positive. So sine is going to be negative. Cosine is going to be positive. Tangent is going to be negative. Cosecant is going to be negative. Cotangent is going to be negative. Cosine and secant will be positive in quadrant 4. Okay. So now we need to know how far away, what is pi over 4 in reference to this? It's 11 pi over 6. It's the same thing if you go, it's the coterminal angle. But if you use the reference angles for negative pi over 4, you'll find that that angle is pi over 4. So it depends on how you want to handle this. If you want to use the 11 pi over 6, which is negative pi over 4, your x value is going to be square root of 3 over 2. And I might just use reference angles, use the 1/4. I'm sorry, use pi over 4, which is 1/2, because I've already got my signs there. So the signs don't matter at this point because I've already picked my signs. So now I've got my cosine, I've got my sine. Done. Now I need my tangent, which is sine over cosine. So sine divided by cosine. Keep, switch, flip. Gone, gone. So 1 over square root of 3, rationalize, negative square root of 3 over 3. There's my tangent. Cosecant is 1 over the sine. So 1 divided by sine. 1 times 2 over 1, which is negative 2. Secant is 1 over cosine. Keep, switch, flip, rationalize. And then cotangent is cosine over sine. Keep, switch, flip. Done. Okay, cool beans. If you have any questions, please feel free to message me and let me know. I think from what I remember, whenever I give these types of exams, if you have questions on anything, please reach out to me. The only thing that you're not going to be really prepared for is one word problem, because I'm not going to make all my word problems look alike. You need to be able to handle different situations. So do everything you can to make sure you understand this, and then let me know what I can do to help you. All right. Have a great day. Good luck.